Welcome back. In this video I'll be solving Leetcode problem 1079, letter tile possibilities. So we have n tiles where each tile has one letter printed on it. Return the number of possible non-empty sequences of letters you can make using the letters printed on those tiles. Okay. So yeah, this is backtracking. How do I know it's backtracking? Because we need to generate. We need to find all possible non-empty sequences of letters. So that smells like a backtracking. So let's try to do that. What do we have? We have input. I'll call it count collections dot counter of tiles. Backtrack. I don't actually need anything. And I'll return backtrack. And how do I backtrack? So let's first say result is 0. And what essentially backtracking? So we are exploring all the possibilities and we are making choices. I saw one great video on backtrack. I'm not sure who is I think programming Brad or something like that. Searched on YouTube. But essentially we have to make choice, we have to traverse through the choice and then undo the choice, and that's it. And for each combination, for each possible choice. So what are our choices here? Our choices here are to use at each step a separate letter. So it mustn't be so let's say we won't use A 2 times. Meaning first letter we only use how to explain it. So let me write it down, maybe that will be better. So for essentially letter in count, which is actually key. So for each letter I do count of L minus 1, so decrease it and choose it. That increases my combination by 1 because I chose it. What backtrack gives me? Backtrack of, or just backtrack. But I do it if count of L is also greater than 0, because I don't want to do it when there is nothing. I add that to the combination, I backtrack, and now I increase my L plus equal 1. And in the end I just return res. And that should be it. Now let's go through it, or let's try to run it just to see if it's good. So seems accepted, submit, it works. But let's go through it. So we counted all letters we had. So these numbers of, let's see, A, B, an example. So I have A, B. So I have dictionary that contains key A and the value is 2, and key B, the value is 1 for that key. And I call backtrack. I return backtrack. Backtrack uses the original count, and I have now letter A and B. And first I will choose, let's say, letter A. There is 2 A's. I will decrease it by 1, increase one possible result, which is just A, and call backtrack with the new count, because count is currently with the choice of the first A. And then I choose the second letter. And then I undo the choice. I travel that path, and that path only leads me to, well, not only, but it leads me again to letter A, because I have one occurrence of letter A and one occurrence of letter B, so that explores those two paths, or let's say permutations of the letters. And when I get back, I will also explore B, then BA, and then BAA, and so on. So I hope it makes sense. I think I'll do more videos on backtracking, because that's something I'm also not so experienced with, so it's a good thing to solve these tasks. For the time complexity and space complexity, so space complexity should be of 1, because we have 26 letters, so time, space complexity of 26, but I'll call it of alpha, or even of 7 in this case, because we only have 7 possible letters. I would keep it of 1 here. And time complexity should be, in worst case, we have 7 separate letters, and that will be I'm not sure if it's this one or I think it's this one, or 2 to the n. Oh, I meant to write it here. If I have 7 distinct letters, I'm not sure about this one. 2 to the n. Okay. So this was better than I thought. As I said, I'm not so experienced with backtracking. I will work on it, so there will be more problems with it. And yeah, I hope I'll get those complexity better next time. If you have anything unclear, just write a comment and I'll try to answer. I appreciate you for following this one, and see you in the next one.